In this video, I'm going to walk you through setting up the 10x probe before we actually take a measurement with it. Of course, to use a 10x probe, we need a 10x probe, but there are two other important ingredients that we're going to need as well. One is the interface board that goes between the pins of the 82 and the BNC adapters that we need to connect to the 10x probe itself. Included also are BNC adapters that come off and go to the waveform generator that we're not going to use in these examples. And then finally, a third important item that we need to use the 10x probe is this little screwdriver. I'm going to show you in the next video where we use it in order to compensate for the 10x probe to get high bandwidth measurements. So these are the ingredients. Now we're going to connect them in. So we're going to slip in the BNC adapter, and there are two important things to pay attention to when we look at the BNC adapter. The first is that we have these flags sticking off here. And these flags are really important because they come from the factory set for AC coupling. We want to use them in DC coupling. And so you have to read very closely, move the blue flag all the way over to the left side in this orientation so that it's connected to DC. And I've done that for both channels. There's rarely a situation where you need AC coupling. DC coupling will get you 99.9% of all the applications that you have. So I strongly recommend set that switch to DC and just leave it there. Second thing to keep in mind is, remember, all along we've talked about the 1 plus and the 1 minus channels from the 82 scope. We've talked about those as being differential. We're looking at the difference voltage. Well, when we use the BNC adapter, on this circuit board, we are literally connecting the ground of the 82 to the -1 channel and the -2 channel of the 82. And so that translates what was a differential measurement into a single-ended measurement. All we can measure with the 10x probe is a single-ended measurement. Always be aware of that. And that's going to be one of the important limitations. If we have to do a true differential measurement, then we're going to want to use either the discrete wire harness that we've been using before, or we're going to use discrete wires that are still connected onto the ribbon cable to provide that low loop inductance. But for most other measurements, the 10x probe is going to be just fine. In addition to only doing single-ended measurements, there's one other important limitation, and that's the fact that it's a 10x probe. That means that between the tip voltage over here and the voltage over here that goes into the scope, there's an attenuation of a factor of 10. That means that if we want to look at 100 millivolts at the tip, we're only going to get 10 millivolts at the scope. And there's a limit to the noise in the scope and how low voltage we can measure. Generally, if we're looking for a voltage level that's less than about 10-20 millivolts at the tip, don't use the 10x probe. And I'm going to show you a trick we can do to turn the 10x probe into a 1x probe in those specific cases. But again, there's a limitation. Everything in life has a trade-off. And if we use the 1x probe, we can see the tens of millivolts of signal at the probe tip without the attenuation, but we significantly cut down the bandwidth, or in other words, the shortest rise time we can see is much longer when we use the 1x than the 10x, and I'll show you why as well. So those are the important limitations. Generally, unless if your signals are above the tens of millivolt kind of level, and if they're single-ended, then the 10x probe is a really good probe to use. I always recommend starting with it unless you have a strong compelling reason otherwise. So first change is we make DC connection. Second, let's plug it in. We're only going to look at one channel for now, and we're just going to plug it into the Arduino signal as a reference signal. And again, because we have the pins, the female pins on the Arduino, to make it a convenient connection, we're actually literally going to use small little wires sticking into the header pins of the Arduino, and then making contact to the clip on the ground lead and on the tip on the 10x probe. And so we've got it plugged in. We're all set to go. And now let's take a look at the measurement on the scope. Now remember, rule number 9, we should see a 5-volt signal, right? And, pretty fast rise time. And it's set for about 500 hertz. Let's take a look at the scope measurement now. Now, as soon as we run, we'll turn it on. Again, I'm going to turn off channel 2 because we don't need that. We see our signal, and look, it reads a half a volt. That's not right. That's not supposed to be a half a volt. It's supposed to be 5 volts. What's going on? Remember, I said that this 10x probe is an attenuating probe. So whatever voltage we have at the tip here, by the time it gets into the scope, we're getting 1/10 the signal. So a half a volt signal on the scope is really 10 times that on the tip, or 5 volts. Boy, it's going to be really awkward if I have to remember to read on the scope scale and then multiply by 10 to figure out what the voltage at the tip is. I don't want to have to do that all the time. I just want to read the voltage on the scale. And there's a built-in feature to let us do that. You go to the little settings tab, and you'll see here under attenuation, we can tell it what's the attenuation of the probe. Well, the attenuation of the probe is a 10x probe. And now we'll automatically do the conversion from whatever that tip voltage is. We want to display that tip voltage on the screen. We take the measured voltage, we scale it by a factor of 10 just to replot it, and now we're measuring, or we're displaying, the tip voltage on the screen. So let's bring that back on scale, and here's our 2 volts per division. And what we're seeing on the scale, and I have to adjust the trigger level here, what we're seeing on the scale is the tip voltage displayed. So really important to set that. So first is we set the DC connection on the hardware of the BNC adapter. Second is we adjust the 10x attenuation setting in the scale. Third thing that we want to do is just make sure that the adjustment over here on the 10x probe is set for 10x and not 1x. And we'll see a little later where the 1x comes in. And then the fourth important thing that we want to do is make sure that when we make the connection to the device under test, we're using as short a connection as practical between the signal of the tip and the return of the tip. Yeah, we have this long loop here already. We just don't want to make it any longer. For signals with a bandwidth of 35 megahertz or lower, roughly 10 nanosecond rise times or longer, this long loop, as we'll see in a minute, is really okay. It's not going to distort the signal very much. It's certainly an acceptable level. If we look at a rise time that is shorter than 10 nanoseconds, in other words, using another scope, then we're going to want to do what we can to reduce the loop inductance of that tip, and that's where using a special ground clip on the end is going to come in. And we're going to use that when we look at some of the circuit board connections as well, because it makes for a very convenient way of connecting into some of our circuit boards. But for now, using the ground lead and short wires is perfectly acceptable, and it's convenient. And I'm going to show you the we will not see an impact of those connections in the measurements that we're doing. Those are the important 4 steps in setting up the probe. So we want to adjust the AC to DC, make sure that we're on the 10x and not the 1x, short wires connecting to the device under test, and then lastly is set up in the scope the setting for 10x. And those are the things that we're going to do before we look at before we actually look at the measurements. And in the next video, we're going to look at the most important step in using the 10x probe after we've done those 4, which is compensating the probe.